Today my topic is hardening and tempering. So what is the hardening? So it is one of the most important process of the heat treatment, in which process the metal is heated at 30 to 50 degrees Celsius above the upper critical temperature. So you can see this figure. This is the lower critical temperature. Most of the metal having the same lower critical temperature. Lower critical temperature 7 to 3 degrees Celsius. The metal is heated above the upper critical temperature. This line is represent the 9-10 degree Celsius. This is the upper critical temperature. The metal is heated above the upper critical temperature. How much? The 910 plus 30, 940, 910 plus 50, 960. It means that the metal is heated in this range 940 to 960 degree Celsius. The metal is heated. The 0 up to the 0.8% carbon. This area is called the hypoeutectic steel. The above the 0.8% carbon, this area is called the hypoeutectic steel. The carbon is represented on a horizontal line, and the temperature represented on a vertical line. The hardening. So after the hardening process, those materials are obtained. The metal is to be hard. So what is the hardness of the material? It is the ability to metal to cut the other metal, indentation, scratching on the other metals. These points are here. The hardening. Number one is to increase the hardness of the metal. Number two, to enable to cut the other metal and also indentation of the other metals. The cooling medium. The cooling medium are generally take the four types: water, oil, air, and furnace. The water and air, the metal is heated in this area. This is the austenite. The metal is heated and drop in a water. You can get this structure of this material. The austenite is changed in a martensite structure. The austenite as a cooling oil are used to very fine perlite. The cooling air, the fine perlite. The cooling is used as a furnace, is a coarse perlite. The water and oil are generally used for the hardening process. The air and furnace are for the normalizing process, and also used in a tempering process. This cycle is represented. You can see this cycle. The metal is the temperature is along a vertical line. The time is along a horizontal line. The metal is heated, the temperature is rise and suddenly cool in a water and oil. This process is called the quenching process. The austenite is changed into the martensite. They suddenly drop into the cooling medium. This is the hardening process cycle. The cooling are generally depends upon the shape and size of the metal. The cooling are generally the heating. The hardening also depends upon the composition of the metal, medium of the cooling, and thermal property, and size of the components, and shape and size are also the hardening are depends upon. In a water cooling, the hardness of the metal 65 HRC. You can get the 65 HRC. When the oil are used as a cooling, the 40 HRC you can get. The air 35 HRC. In a furnace 20 HRC. These are the hardness of the metal you can get according to the use of the medium. The tempering means the hardening. During the hardening process, when the metal is suddenly drop into the water and oil, they change into the martensite and very fine perlite. There are more chance to set up the internal stresses. The internal stresses are very dangerous for the material. When the suddenly force are applied on the components, the metal will be the break due to the setup of the internal stresses. So how to remove it? The metal is again heated at the lower critical temperature, at a lower critical temperature, to maintain, to remove the internal stasis from the steel, and also control the brittleness of the metal. The tempering process are generally three types. Number one is low tempering. The low tempering will be obtained 150 to 50 degree Celsius. Medium temperature, the temperature will be used 300 degree Celsius, 450 degree Celsius. For high tempering, 500 degree Celsius to 600 degree Celsius temperature are used for the high tempering process. This is the cycle, is represent the tempering. The metal is heated, the workpiece is held in a furnace. This holding a time is called the soaking time. The whole time in a soaking time. The metal is cooling as a furnace, for a water and tempering. It means that the metal is slowly cooling. So the curve is formed in a curve form, not a straight form. The straight form are represented the hardening. The metal is suddenly quenched into the water and oil. This is the hardening process. So how to check the hardness of the material? The hardness of the material are checking by the different method. Number one is Brinell hardness. Number two Rockwell hardness. Number three weaker hardness. Number 4 is micro hardness. This is the hard ability. The hard ability are also measured by this. This is the specimen with a 100 mm length, 25 diameter. The collar diameter should be the 31 mm. This is the Gemini process system. So the water is applied on a hot surface at a high pressure. The hardening is gradually increase. After some time, the hardness is decreased, and again is make this like this. So because the curve is not meet at this point. Why? Most of the metal have the some there its hardness. So and also the heat is transferred at a coefficient. The heat is increased at a low level, so that this curve is performed. So this curve is performed from the zero level. This is the distance. This is the hardness of the metal, HRC level. This is the method of checking the hardness. This is the hard ability. The hardness and tempering play a very important role in engineering to hardening the punch and die, and to increase the production of our the components. Hardness and tempering play a very important role to increase the mass production. I hope that you will like my lecture. Thank you very much.